Now let's look at more examples about the limit from the graph, finding the limits from graph. Okay, so this is the example that f of x equals 1 when x is not equal to 3. When x equals 3, it's equal to 2. So the graph will be this one. So here is 3, for example. Here is 1. Here is 2. Okay, so the graph would be a horizontal line when y equals, for y equals 1, but when at x equals 3, it's a circle, because when x is 3, it's not equal to 1. It's equal to 2, so we have a solid point here. So this is the graph for this function f. So we want to look at the limit. The limit of this function f of x when x approaches 3. So now we know that when x approaches 3, that means two things. X approaches 3 from the right side of 3, and x approaches 3 from the left side of 3. It's 3 minus. So that means x is less than 3. So now let's look at when x approaches 3 on the right side of 3. So this is the red arrow denotes the x values. Okay, this is the 3 plus, right? Approaches 3 plus. And this is the 3 minus. But pay attention here. We care about the f values, not x values. Okay, so many students will make a mistake. Then they say, okay, x approaches 3, so the result would be 3, because these two red arrows will point to 3. But remember, this is the limit for the function f, okay, not x. So we need to care about the f values when x approaches 3 from the right side of 3 and from the left side of 3. So when x approaches 3 from the right side of 3, then the f values will be on the curve, right? Which will go this way. When x approaches 3 from the left side of 3, the f values will follow in the curve go this way. So the limit of this function f when x approaches 3, we will care about the tendency for these two blue arrows, not red arrows. Okay, so these two blue arrows will point to this hollowed circle, and this hollow circle has the f value, which is what? Which is 1. So the limit is 1. And here we also notice that this function f, when x equals 3, we know it's equal to 2. So you see from this example that this limit when x approaches 3 for this function f, which is not equal to the f values at x equals 3. So this example also shows the limit is all about the tendency, not the exact values for these functions. Now let's look at another example, which is the function f of x equals sine of 1 over x. Okay, so we want to know what is the limit when x approaches 0 of this function sine of 1 over x. Again, you cannot plug in 0 directly because the denominator would be 0, right, for the 1 over x. So if we know the graph for this function, the graph will look like this one. right? When the x approaches 0, the graph will oscillating between 1 and negative 1. Okay, we're oscillating between 1 and negative 1. So here, so sorry, this is not a very good graph. Okay, so this looks like this one. So when x approaches 0, so the graph, the values under the curve will oscillating between negative 1 and 1. So that means it will not tend to specific numbers, right? It just jump between 1 and negative 1, and there you can see you cannot find a number when x is very close to 0. The f values will point to certain numbers, no. So that means this limit does not exist.